Hello everyone, welcome to our next video, which just recaps the basic idea of equivalence classes that we looked at this week. We began by thinking of a big set made up of both my higher level classes, and we thought if we make this set S and we have a relation R such that X is related to Y if and only if X and Y have the same number of letters in their first names. Is this an equivalence relation? Well, try it by yourself for a few minutes. It is. And then we imagined all of you, i.e. the set S. Hey, don't do that. The set S. Wait a minute. Oh yeah, here we go. The set S coming into class and me asking you to stand with the people that you are related to under this relation. You have to stand with the people who have the same number of letters in their first name as you do. And this is what would happen. Here we have what we might call the equivalence class of Natalia. What does that mean? It means the set of all people in our big class such that X is related to Natalia. Whoops, wrong bracket. And so on. Here's the equivalence class of Ilias. Here's the equivalence class of Eustace. Here's the equivalence class of Yuka. Victoria is in an equivalence class of her own, as is Anna Maria, as is Alexander. And we agreed that the equivalence class of Victoria must have at least one member, because with an equivalence relation it must be reflexive, and that means each and every member of S is related to itself. So we are guaranteed that Victoria will at least be related to herself. It happens that nobody else in the class has, 8 letters in his or her name. She's the only one. But that doesn't matter. She's still in the equivalence class of herself. And then we reflected on the fact that these sets that I've circled include everyone. Moreover, there is nobody in both. It doesn't exist. This is called a partition. And then we thought, well, let's experiment a little bit further. Supposing we change the relation so that X and Y are related if they have the same number of syllables in their first names. Not letters, syllables. I might have made a mistake in this one, we'll see. Is it an equivalence relation? Yes, it is, because it's just basically equals in disguised, or dressed up a little bit. And equals is the easiest equivalence relation you can have. Okay. So this is what we had previously when we were looking at the number of letters. But I'm going to change the rules. It's going to be syllables. Let's see if I can do that. as if by magic. Now we've transformed it. Anna Maria's still in a class of her own. Let's look here. Natalia. That's 4 syllables. Victoria, yeah, same thing. The equivalence class of Yuka is now many people. 2 syllables. Okay, but again, it's still a partition. Everyone's in an equivalence class. The union is the whole of S, and nobody's in 2 equivalence classes. It's actually impossible. So that's what equivalence classes are. So the definition of a partition is here. So the intersection between any 2 of the sets is the empty set, and the union of all of the sets is the universal set. And the fact is, always an equivalence relation on S partitions S into sets, which are called equivalence classes. Okay, that's just an introduction to the concept of an equivalence class.